Glad to be here today. I'll speak briefly about our transition from backup power systems and traditional grid infrastructure as we move to a more integrated microgrid solution that addresses the requirements beyond just simple backup power without compromising the mission. So Eaton's had a long history of working with the federal government and the Department of Defense to ensure the integrity of power systems so that mission-critical assets are available. So a little background for us. Our work over the last 35 years has included a lot of different power system applications for the Army Corps of Engineers, the Air Force, FAA, DISA, a number of different federal agencies. A common aspect of most of these mission-critical applications has always been the trusted genset. And we'll continue to hear about gensets, I think, for a long time because they are very trusted. Typically, these are applied with uninterruptible power supplies, especially historically as well as currently. Lots of UPSs out there, in particular when there's critical telecommunications or IT assets to protect, which is virtually now every mission-critical facility's got some element of that. So this solution is very reliable, and now with mature technologies, it's also very cost-effective. So why would we actually change anything? So one of the things that we see is that advancing resiliency goes beyond really the traditional emergency backup system. The fundamental reason that this approach, or the current approach, is insufficient is not because it doesn't work. It, in fact, works very well in the way it's intended. It's because the assets are really waiting to operate in the event of an emergency, and they're not really being utilized to do anything else. So you've got kind of invested capital. It's available for the emergency, but it doesn't really take advantage of the operational efficiencies for day-to-day. It also doesn't take into account, in most cases, the integration of renewables to combat climate change. And as I think most people are aware, hopefully in this room, maybe not everywhere else, when you lose your utility power, you are going to lose your renewable power. So you've got another complexity there if you're trying to do multiple things in different ways in the same location. So advances in technology now allow us to better integrate these various sources and loads, I think, into a more efficient and more flexible microgrid system. Just some observations here. You know, the Department of the Navy's Resilient Energy Program recognized the benefits of implementing projects that are resilient with alternative energy and renewable energy. So I think generally people are starting to see that there's a better way to do things. I think we've actually already heard about that to a certain extent. So energy resilience, the microgrid advantage. I thought I'd take us through just a kind of a history of where Eaton has been as relates to the Department of Defense, which I think in a way mirrors where the industry is going and where we are today. We started working with the Department of Energy about 10 years ago, and we deployed a number of projects. So I'll talk about a few of them here. One of them, for an operating basis, the resiliency challenge there is different than it is in a stationary U.S. Military base because the mission success depends on reliable access to fuel. So that becomes your critical path, and that's of course expensive if you're somewhere where you've got supply lines. And it's also a safety issue, right? There's an aspect there. So looking at solutions for that, we have what we call our intelligent mobile power distribution system, which is a small portable microgrid that controls a reliable system of generators that match the output of the generators to the real-time loads. And what that really means is that you can significantly reduce the diesel consumption. So it's an efficiency play. What we saw was improvements of around 30% in terms of the reduction of diesel consumption just using traditional gensets. So these are the typical gensets that the Army might deploy as a standard product. So significant reduction in diesel fuel. And if you move forward a little bit in time, and this goes back a few years, and you look at Fort Sill, there was a general kind of recognition that everybody's talking about microgrids, but show us how it's done, show us a campus, show us a base where this has actually worked. So we worked with Fort Sill on a full-scale microgrid demonstration project in Oklahoma, and we were able to demonstrate that we could operate off-grid, balancing solar, wind, natural gas backup power, and stored energy And the other important thing, I think, as we look at what we're hopefully will be working on in the future is that we can reduce the cost of implementation by using existing assets or getting multiple purposes out of those assets. And if we scroll forward a little bit to today, where we're working at Fort Custer on the training center in Michigan, we're working with the Environmental Security Technology Certification Program, ESTCP. It's a mouthful, but an important program. And what we're working on there is a way to establish a replicable model for reducing the overall cost to implement energy surety, while also proving what we like to believe is actually proven technology. So that particular microgrid will be able to island from the utility, including the critical power needs of several nearby federal installations. So some flexibility in terms of how it will support the mission. And it'll also support distributed generation management and demand response and other use cases where you can take advantage of the microgrid for day-to-day use to reduce operating costs. So consistent, I was really glad Eric actually showed the math on some of the concepts that we're working on as we go forward. But you know, getting a hybrid system where you're taking advantage of the best of both worlds, you can kind of see in the graphic there the ability, for example, to take a system where you have UPSs and gensets, which is the traditional approach, having more storage within the UPS, and then actually being able to utilize that for day-to-day purposes if you size it correctly, so that you get the benefits of the microgrid, but you also have that trusted and true architecture for your reliable power. So you get some resilience, you get some renewable benefit, and you also get a system that's easily deployable. Another important aspect that we've seen over the years of working with microgrids is actually the idea that you want to really know what it is you're getting into before you actually deploy assets. And you know, every mission critical system has its own unique application scenarios. You know, this mission over here is not the same as that mission over there. You really want to know what you're doing. And what we've seen is actually simulating and testing the environment in a controlled environment, that is. You can make sure that the system works not only as it is intended, but you can get the most out of it, both financially and from a reliability standpoint. The other benefit you get from this is once you've created that digital twin or that virtual microgrid, you're actually able to then project changes in the future. So if a few years later you want to add additional assets or loads, you can model them before deploying real money or putting a shovel in the ground. So an important way to do that. We've got a microgrid demonstration, which is actually a functioning microgrid in Pittsburgh. Love it if anybody was interested in seeing it. Ask me questions or come talk to me later. Would love to invite anybody that's interested to come and see that. So overall, you know, what we've seen is that the best and most effective resiliency strategy is, in fact, an integrated strategy. It's not an either or. I think microgrids really need to take advantage of the mixed use of generation assets. That's a clear way to make sure that you've got flexibility in the event of an emergency, so you can adapt to the current circumstances. But from a day-to-day basis, you can also take advantage of reducing the carbon footprint and other financial benefits that you can get from a microgrid. So I look forward to hearing any questions later on. Thank you.